My name is Michael Redford. I'm a PhD student at the Scottish Association for Marine Science. I'm a University of Highlands and Islands PhD student, and I'm currently working on a PhD in artificial reef creation from decommissioned pipeline protections.
These pipeline protections, often called mattresses, can you describe what they are? What do they actually do?
Yeah, so pipeline protections are used in the offshore oil and gas industry to protect pipelines from various forms of damage. It can be from dropped objects from the surface, hydrodynamic forces, or even from snagging from trawled fishing gear. There's a couple of different types. There's concrete mattresses, which are large concrete blocks made up of lots of smaller concrete blocks joined together with polypropylene rope. And then there's also rock dump, which is like quarried rock, about 25 centimetres diameter, that's deposited on top of pipelines to afford some damage in that way.
This will be new to some people. How extensive are they? How much of it is there down there in the North Sea?
So in the North Sea at the moment, it's been estimated that there's around 40,000 mattresses still on the seabed, and most of those will need to be accounted, or all of those, will need to be accounted for in the decommissioning process. There's also a vast amount of rock dump as well, which needs to be accounted for.
And this is a different texture, if you like, to the surrounding seabed, so provides opportunities for colonisation?
Yeah, so the North Sea is predominantly sandy based. There is some coarse sediment and gravel, but most of it is sandy based. So the introduction of a hard substrate like a concrete mattress, any man-made hard substrates that are put into the marine environment have the potential to be colonised by marine organisms.
So how are you trying to establish whether these particular mattresses are in that category of being suitable?
So my work has started really with looking at what's currently using the concrete mattresses that are down there. So we've gone around to oil and gas operators. I've got my hands on hours and hours of ROV footage, and I've trawled through that from the northern North Sea, the southern North Sea, from various different depths, various different areas inside and outside of platform safety zones and things like that. And I've quantified the number of benthic species and the number of fish that are observed, and also identified them to taxa level. And what I've done with that is created some statistical models that have then sort of shown us where we're more likely to see certain species, which structures are hosting the most amount of species, and so on.
And you're still obviously analysing that and probably doing more collection of data. What's it telling you so far then?
So far what the data has shown us is that almost all of the species that we've observed on pipelines, rock dump and on concrete mattresses are in higher abundance on concrete mattresses. So we've found that grazers, for example, are nearly 3.4 times higher in abundance on mattresses than bare pipelines. Pollock even are 1.27 times higher on mattresses than bare pipelines. And we're finding the same with most of the fish and benthic species.
So ecologically positive, is it just a question of leaving them there and hoping that you can maintain this diversity?
So in the decommissioning process, there's lots of that they do what's called a comparative assessment, and they look at all the different options for decommissioning these structures. Some argue that perhaps in situ decommissioning is a suitable way of doing that, in which case these structures may continue to serve as artificial reefs exactly where they are. But there's also the option to bring the mattresses up and repurpose them or reuse them in other areas of the marine environment, perhaps using them as scour around wind turbines, perhaps breaking them up and building purposefully built artificial reefs rather than de facto ones from leaving them in situ.
And what's next for you, the mattresses, your PhD?
So my next step is I'm creating a load of 3D models of those potential artificial reef situations that I described. So I'll be placing mattresses in situ. I've been given some decommissioned mattresses, and I'll be recreating the scenarios and then photographing them hundreds of times, building these 3D models, and then from those I'll be able to extract some complexity measurements. So I'll be able to use some software to work out distances and work out a complexity value. Those complexity values will then be compared between the different scenarios, and we'll be able to infer the faunal occupancy of those structures. So we'll be able to estimate what sort of species would be using them, and identify any potential population bottlenecks or habitat bottlenecks, which is quite an interesting and really important factor in artificial reef creation. The population bottleneck is basically where we've created a structure and species have started to colonise it. They're using the complexity, the structural complexity, they're using the refuges and the nooks and crevices. But a population bottleneck occurs when there isn't enough complexity, when that species would reach a later stage in its life cycle. So a good example would be a lobster. We may have loads of juvenile lobsters on a structure, but if there isn't enough complexity to offer them habitat when they get to a larger stage, then they're either going to disperse from the structure or they're just going to die. So we need to make sure that the scenarios we're recreating do offer enough complexity.